Once again, now good morning. Because
Morning.
Morning, sir.
Morning, sir.
Good
So
morning,
let's start
sir.
with number one. Now we are going to begin with number one. So presenting number one, we will draw. No, we are going to draw our axis because we will start it with a graphical method. No? So for a graphical method, we will have now to indicate north first. No, so 40 meters north. So we will mark 4 segments. So our scale is still 1 unit is to now. So 4 segments. Now and then we draw our next line. Our next line is going east, guys. No? So it will go east like this. No? And this time we will only mark 3. No? So 1, 2, and then 3. And again, now we indicate that with an arrow. So let me color my vectors now as red. So this is the first vector. The next vector goes to the right. If you are to label it, no? So labeling. So this will be called your D1. No? Okay, that's displacement. So D1 is 40 meters. Our D sub 2 is 30 meters. And our question now, since these are not needed anymore, I'm going to erase questions. I will erase this. No? We don't need them. So these are our vectors. And this time, now we are going to draw our resultant. No? So our resultant, we will color it green. So obviously, by our tip to tail method, no? So this will be our resultant. And again, if we use our scale, and if it's a graphical approach, no? So graphical method require us to have a scale. 1 cm is to 10 meters. And therefore, no? Since we've gone this through last time, so therefore our FR, I could just write it. No? If you will use your ruler and protractor, eventually you'll end up with a value that is 15 newtons. Do you agree? Am I right there? No? And therefore, if you're
Yes, sir. Sir.
you're going to, yes, that's 15 newtons because tama ba 15 na, no? Because there will be 5 segments on the side. So 5 segments times 10 is 50. No? Now our theta is now indicated by this angle. No? So that's our theta. And how much is our angle using your protractor, please?
53, sir.
So this is 53.13. Tama? Ay, 53 lang. No? 53 degrees. No? And that will be north of our east. No? Now that's not a 0, but it is an angle theta. No? So our angle is indicated from the horizontal line going up. No? So that's north of our east. No? Now, that's graphical approach. What's our analytical approach? So analytical approach is, so analytical method will involve Pythagorean. So we will write or use our Pythagorean theorem. No? So let's just have that TH. No? So Pythagorean theorem will allow us to have now our equation that FR na, is equal to the square root of the two sides, so, which are the squares of the two sides 40 and 30. And this is now our square root value. No? So we square each of them. Sorry, no? So we square each of them. And that gives us FR value to be equivalent to, ilagay natin FR value di? Obviously, it is still 50 gap.
50, sir.
That is still 50 newtons. No? Okay, now our angle, this time around, our angle no, will be in terms of tangent of theta. And tangent of theta is described as opposite over adjacent. So our opposite side no, is your value 40 divided by 30. No? So therefore, theta is equal to tangent no, or arc tangent, or that's the tangent inverse nga value. That's arc tangent of 40 divided by 30, which gives us 53.13 no, degrees. And if you include the direction, that's north of our east. No? So the two values no, always needed for our vector. No? So a magnitude and a direction. No? So let me draw this now and have this one. No? Okay, so this is using our basic knowledge of previously. No? So we get these two values, obviously. Okay, next, no? We go to number 2. But I got to, I have to probably, no? Delete no, this one. Can I now erase this, guys, the graphical? How many are still copying? Now for our next number, no, let me scroll this up instead. No? Scrolling up no, the page. I will just need a little space. No? So we did not solve number 3, but we only solved until number 2. No? So we will go for number 2 first. No? So number 2, we'll need no, a graphical approach. So we draw no, our vector. So this is our axis again. And then the first value that we are going to indicate is going south. No? So south means we are going to mark 6 units going downward. 1, 2, no? 3, 4, 5, no? And then, of course, this must be 6 probably. Okay, so that's our first value there. And then we will indicate it later with an arrow. Now, we will extend this one going east. Am I right? Yes or no?
Yes, sir.
How long will we,
Yes, sir.
draw here no,
10
for our number 2?
10 meters.
We will indicate it in segments. No? So you'll have 1, 2, 3, 4, 5, no? 6, 7, 8, 9. This is 9. No? And then 10. Okay, so that's 10 segments going east. And then next value is what? We go up. No?
North.
And go north. No? Go north for number 2. So
Yes,
going
sir.
north, guys. No, so we will make it no, in line with our previous line over there on the other side. So this is 1. Hopefully I am in line with the other side. No? 2, 3, 4, and then this is 5. No? That's my 5. No? So let's connect our arrows. No? So the first vector again going down. Sorry, I will use a different color, I guess. No? So we will appreciate the vector. Let's use a different color. Let's use a blue one this time. No? Okay, so we'll try this blue color. So this is vector 1. This is D1, D sub 2, and then D sub 3. Okay, our values of our vector again. So for D1, this is equal to 6 meters. Our D sub 2 equals 10 meters. And D sub 3 is equal to, that is equals to 5 meters. Okay, so we have our 3 vectors and their indicated directions. Now, where is our resultant this time? Where do you think is our resultant? Now, allow me to color our resultant again with the red arrow. So it starts from the starting point and ends on the tip of the last vector. Okay, now I think the answers that most of you got there is around 10 segments. I think there are 10 segments there. So our FR or our DR, I mean, is 10 segments. So that makes it also around 10 meters. That's roughly 10 meters. There's actually a small point there, but that's a very, very small value. So you may not literally see it in your ruler. Now, ang question next is where is the angle? Angle is going down, like this. So your theta, guys, if you are going to get the value of theta, so what is the direction of our theta there? So it is directed at what angle? That's a small value. Please, can I have a value there? How much is our value? Okay, guys, how much is our value?
5 degrees, sir.
So more or less, that's around 5 degrees, And that's still, this time it's now south of, going down, So that's south of your east already, So graphical, So that's our graphical approach. Now, how about our analytical approach for this one, What will be our analytical approach? Analytical method, will it use Pythagorean theorem? Can Pythagorean theorem be used here?
No, sir.
So I say, yes. We can use it as Pythagorean theorem here. And how do we use Pythagorean theorem? You will realize that at the top, I'm looking at the triangle, at the top. This is a triangle. Basically, if I'm going to stretch this all the way here, that will become a triangle. The one that I have here at the top. So that's a triangle. That's a right triangle, actually. And what are the values of this triangle? So one is, the side at the top is 10 units. And the value on the side here is 1. Manang iya nga mga value. So this side over here is 1 unit. This is 10. So therefore, this is also a hypotenuse. So being a hypotenuse, our DR, guys, can be taken by using Pythagorean theorem. And that will be 10 square plus 1 square. And we extract the square root after that. So we'll have to get the square root of that. Sorry. Do you agree that that's a right triangle? Sorry, that's a very fancy thing. Nabudlay ang sulat, guys. So again, now this is square. So that's a squared value. I'm really sorry for the shape of that. Oh, no, that's even worse. So ano na to?